Hey guys, last video for 2.4. Let's make sure we got a big point that I didn't actually say out loud in the last video. By definition, the tangent line to a curve at a point is the line that contains the point and also has the slope that is equal to the slope of the curve, which we found using that definition that we have up at the top of the page. So that's why at the bottom of this page, we were able to say, once we found that the slope of this function, f of x, at the place where x equals 5 was negative 160. And we figured out that when x was 5, y was negative 400. That's why we were able to write the tangent line equation. That's going to be the line with this slope and containing that same point that we found the tangency at, the same point that we found the slope of the curve at. So if that is what a tangent line is, we have one more definition for this chapter, which is a normal line. A normal line is a line through a curve that's perpendicular to the curve at that point. So it's essentially perpendicular, it's not even essentially, it's exactly perpendicular to the tangent line and contains the same point. So the thing we need to remember is that lines that are perpendicular have slopes that are opposite and reciprocal. So we're going to use that down at the bottom of this example when we find the equation for a normal line. Okay, so this last example brings together all of this stuff from 2.4. I'm going to move me up here. I have a function, f of x is 1 over x. I'm going to find the slope of the curve at x equals a. So check this out. I don't even have an x this time. I'm going to find the slope of the curve at like some abstract unnamed x value and watch how it helps me. But I'm going to start with that same definition we used before. The slope of f at the place where x equals a is the limit as h goes to 0 of f of a plus h minus f of a all over h, which is the limit as h goes to 0 of, in this case, f of x is the reciprocal function. So I'm going to take each of these inputs to the f function and make them denominators in fractions. So f of a plus h is 1 over a plus h. And f of a is 1 over a. I'm trying to take the limit as h goes towards 0. I might try substitution, but if I use 0 for h, I'm going to have a 0 in the denominator, and I can't divide by 0. So let me just clean up that a, so it looks more like an a. There we go. So I'm going to go back to my techniques from section 2.1. What can I do to try to make it so I don't have a divide by 0 problem? Well, you might recognize this as a complex fraction, a fraction with fractions in either the numerator or denominator or both. So I'm going to try to simplify this by getting a common denominator so that I can rewrite this as, instead of a division problem, multiplication by a reciprocal. My common denominator for a plus h and a is going to be a plus h times a. So this is going to be the limit as h goes to 0 of a over a times a plus h minus a plus h over a times a plus h. My denominator is h. So notice here we have that first warning we got about working with difference quotients. I have the same denominator now in my two numerator fractions, but when I subtract a minus a plus h, I'm going to have to remember to distribute that subtraction. This ends up being the limit as h goes to 0 of a minus a cancels out, but I'm still subtracting the h. So this is negative h over a times a plus h over h. You probably recognize this from some of those examples from 2.1. This is going to be the limit as h goes to 0 of, instead of dividing by h, I'm going to multiply by 1 over h. This is negative h over a times a plus h times 1 over h. This is that problem that I made 2 mistakes in 2.1. So I'm going to try to get it right now. This h is going to cancel with this h, leaving behind a negative 1. And I'm going to have the limit as h goes to 0 of negative 1 over a times a plus h. Notice now, if I replace h with 0, I'm not going to have a divide by 0 problem. This is negative 1 over a times a plus 0. It's just a times a, which makes a squared. So watch what happened. On the other side of this paper, we did that example where we found the slope of the curve at the place where x equals 5. And we got a 1 number answer because we had a 1 number x value that we used as the point to find the point of tangency, to find the point at which we were finding the slope. If I go through this process more abstractly, I can actually get a formula that can tell me the slope of this curve at any x value. So I have this is going to be very important for us. This is actually the whole topic of chapter 3, is how to find these little formulas. But now that I have it, I'm going to move back to my original problem. All right, so this is what just happened. We found the slope of the curve, f of x equals 1 over x. And we didn't find it at a particular point. We found it like at some unnamed point, a. So we found that that slope was going to equal negative 1 over a squared. So it's interesting because we've just stated now that the slope of this function is related to where on the function you look. So we saw that happen our first couple of days in class when we looked at the natural log of x function. And we found that depending on where we looked, the slope was different. And we could write a formula for what that slope was. So same thing has happened here. Now I could use my formula. If I want to find the slope when x equals 2, m is going to equal negative 1 over 2 squared, which is negative 1/4. Can I write the equation to the equation of the tangent line to the curve at x equals 2? Well, I know the slope. I just found it. The other thing I'm going to need is a y-coordinate. So when x equals 2 and my function is 1 over x, my output when the input is 2 is going to be 1 over 2. Now that I know that ordered pair and I know the slope, I'm going to write y minus 1/2 equals negative 1/4 x minus 2. Point slope form, don't feel like you have to change it or rearrange it. It's perfect just like that. Now, the equation of the normal line is going to be this exact same equation. It's going to contain the same point. The only difference is going to be the slope should be the opposite reciprocal of this slope because the normal line is perpendicular to the tangent line. So the opposite reciprocal of negative 1/4 is positive 4. I'm going to write y minus 1/2 equals 4 times the quantity, x minus 2. All done.